See people joining in. Hey, Jim, how are you?
I'm doing very well, Manoj. How are you?
I'm very good, thank you. It's so good to see you back. I think last time we met on a similar platform was 2022 at TestMe conference.
Yeah, I remember it was great fun, and it's always good to be back.
Absolutely. Yeah, I'm sure this topic also brings in a lot of those fun and answer a lot of those questions around the controversies that we're having around the web frameworks. So I'm really looking forward to this topic like anyone else. And
Great.
I see quite a few people joining already. So a quick piece of information, folks, so great to see you all joining. Just drop a hi in the chat button, as well as if you'll be so nice if you say where you're joining from. That'll be great so that, Jim will be happy to see which part of the world that you're joining it from. Perfect. So we have people joining in from India, London. Hey, Simon is here. Hey, Simon. And Abu Dhabi, Athens. Oh, cool.
Fabulous.
Macedonia.
Great stuff.
Perfect. Great stuff. Thank you. Thank you so much for joining in. I don't want to take much of a time, and I'm pretty sure everyone is excited about today's topic, WebDriver BiDi, the future of test automation. 2 months back, I gave a topic in a Melbourne conference. The title was around a similar title, but it was around all the frameworks surrounding. And since then, a lot of questions were asked about WebDriver BiDi, and I'm so glad to have someone who's working very closely with the WebDriver BiDi spec and the implementation of it. It's none other than Jim Evans. For those of you who don't know, Jim Evans has been around Selenium for a very long time, since 2010, if I'm not wrong. And he's been the sole contributor to the .NET bindings. And I still know some of you use IE browser. I don't want to ask the question how of you still use, which might upset a lot of people from the Selenium team. But if you are still using, you should thank Jim Evans for all the work. Of course, the other team members as well. He's been doing fantastic work. So all the .NET related stuff has been maintained and patiently done by Jim Evans for all this year. So we are so grateful for all your work with the Selenium team, Jim. And today's topic, I'm sure, is not going to be about Selenium for a change. It's all about WebDriver BiDi. And before handing it over to you, Jim Evans for you, Principal Member of Technical Staff at Salesforce for you, talking about all things WebDriver BiDi. Stage is yours, Jim.
Great. Fantastic. All right. Well, let me, I did do a slide deck, so let's do this. It's a little sparse, but we'll talk about it. So WebDriver BiDi is the future of test automation. At least in my opinion, it is. And we are, I think I need to, let's see if I can share my screen here to make sure that everybody's seeing what they need to see. And there, now we should have a slide show up.
Yep.
So WebDriver BiDi, the future of test automation. I think it's important to start when approaching the question of WebDriver BiDi to talk about what is WebDriver in the first place. What is WebDriver at all? And basically, WebDriver is it's a protocol. It's an open standard for automating browsers. It's been a W3C standard, and I believe it went recommendation in 2018. Of course, it was several years in development before that, but the spec went to what's called recommendation, which is the final stage of a WebDriver of a W3C specification in 2018. And it's maintained by the World Wide Web Consortium, which is the W3C, which is a group of companies that all join and individuals who all come together and decide how the web is supposed to work. And they have tons of specifications that describe in detail what a browser should do when implementing a specific type of technology, like, for example, CSS or WebDriver. And the WebDriver protocol is implemented by all the major browser vendors, Apple, Google, Chrome, Mozilla, Microsoft, and WebDriver by itself is used as a backbone for many automation tools out there. Selenium, of course, uses it to communicate and automate the browser. WebDriver IO is another, and there are others that use the WebDriver protocol as the way that they automate the browser for your testing. Now, how does WebDriver work? So if you have WebDriver code in your local end, whether it's Selenium code or whatever, what that does is that uses a JSON over HTTP wire protocol. So you make HTTP calls, gets and posts and deletes to send messages with JSON payloads across to a remote end browser driver component, and that's what I call it, or a browser driver. A lot of people call it. You would know it as things like Chrome driver or Gecko driver or Edge driver or Safari driver or something. It's an executable that launches a local HTTP server to receive these HTTP requests, and then from there, the browser driver then automates the browser the best way that it knows how. For Chrome, that is using the Chromium DevTools protocol. For Edge, it's the same thing because they're both Chromium based. Gecko has, Mozilla has its own protocol called Marionette that it uses for Gecko driver and Firefox, and so on. So, and by doing that, we get browser agnosticism. You have a standard way to talk to whatever browser you happen to be running against whatever browser you're running. You have a standard way to automate it using the same protocol and therefore the same API. Now there are some limitations in this. First of all, there is you do need this browser driver component, and for some that for some frameworks that's easier than others to keep that maintained. Most of the frameworks nowadays have some sort of manager to handle making sure that the browser driver that you have is the right version for the browser that you're trying to automate. But that's one limitation, is that you do need that browser driver component. Another limitation is that it's HTTP. So, and specifically HTTP 1.1. So you get only one way, one directional communication. You from the local end make a request to the remote end. The remote end gives you a response back. So these are some limitations that you have with the WebDriver protocol. And honestly, times have changed. People have started to expect more out of their browser automation utilities than they used to. So those of us who worked on the WebDriver specification, and I can show you where that lives on the web. It's available on the web, where you can search for WebDriver specification in your favorite search engine, and it'll show up. Those of us recognized that there were some limitations, and we wanted to overcome those and sort of modernize the specification to handle more modern scenarios. So we are working on what we've termed WebDriver BiDi. The original WebDriver we're starting to call WebDriver Classic. That's just how we're terming it. That's not an official term. That's just one that we use colloquially. But WebDriver BiDi standing for bidirectional. So WebDriver BiDi is a new protocol that's being worked on, and it too is an open standard for automating browsers. It's an industry standard open specification. It's currently being written. There are changes being made to it on an almost daily basis right now. The workflow for making changes to the specification is a GitHub workflow. So people submit pull requests to the spec for the spec language, and those go through a review process. And once they are approved and merged into the main branch of the spec, they become part of the working draft of the specification, and then it's up to the browser vendors to implement that portion of the specification. The authors include people from all of the major browser vendors, just like for WebDriver Classic, Apple, Google, Microsoft, Mozilla. It is also being done under the purview of the World Wide Web Consortium, the W3C. And this all happens in the open. Anyone can participate. It's a standard GitHub repository. If you have an issue with the specification or a feature request, you can file an issue or you can contribute PRs to the specification. It's all done in the open. It's not proprietary. It's not it's not controlled by any one particular company or one particular organization. It's all done in the open collaboratively among all of the members of the World Wide Web Consortium and the working group that works on it, on the specification. So how does WebDriver BiDi work, and how is it different from WebDriver Classic? Well, unlike WebDriver Classic, which uses HTTP, WebDriver BiDi still uses JSON as its payload mechanism, but it's over a WebSocket instead of using HTTP. So what that means is that you can send commands directly into the browser, because the browser already is capable of starting up a WebSocket on its own and receiving messages across a WebSocket. So a browser driver is no longer required. Now, hold on to that thought for a minute, because because it'll come back. We'll come back to that later when I have some demo code that I want to show. But the idea is that you can send your commands from your local in WebDriver BiDi directly to your browser, which understands the WebDriver BiDi protocol, and you get command responses back. You tell the browser to do something, you get a response back that says that it succeeded or didn't succeed. But the interesting case, the new thing, is that because it's a WebSocket, and it's a bidirectional communication mechanism, what that means is that the browser can send events back to the local end without having to have a command running at the time, which opens up a whole lot of additional new scenarios for automating things. And I'll show you a few of those in when I get to the demo. I've got a fair amount of code to demo to show you just kind of how the protocol works. So let's just dive right into that. First of all, let's since I'm out of the slideshow. Oh, one more thing. All the stuff we'll make the link to this presentation available. There are some important links here for where you can find everything that we've talked about or are talking about today. Here's some important links there. Those links are stable. They should not go anywhere. And those will be in the slideshow. We'll share a link to the slide deck through other means. But let me go ahead and start off with a couple of things. First of all, here's I mentioned the spec is done through GitHub. This is the GitHub repository for the specification. This is and here are the current extant pull requests and the issues that are currently open against it. And so that's and here is the current editor's draft of the spec. It's generated when new things land in the specification, and you can see here's how things are defined for how a WebDriver client should work. An interesting question would be, how do we know that a browser vendor has appropriately implemented part of the spec? Well, that's a very good question. There is a set of tests called the Web Platform Tests, and it's maintained by members who work on specifications. Part of landing a PR for a patch in the specification is that you also want to write tests that test that the implementation does what the spec says it does. And there is this great dashboard called WPT.FYI, Web Platform Test, WPT. And the tests are grouped by specification. And so here's the WebDriver tests here. Here are the classic tests. Here's all the tests for all the commands for WebDriver Classic. But here we have tests that have already landed for the WebDriver BiDi. And you can see what the implementation is, and these get run on a regular basis. You can see these were just run earlier this morning, as of today, November 21st. That's today. So this was the last time it was run, and this is what version of the browser they were run against. By default, they show the experimental or canary or daily, nightly build of the browser. They also run these tests against stable channels, and you can change what what version of the browser you're looking at. But so at any rate, this is where you can see where the implementation is of the specification, and how the browser vendors are doing in implementing the portions of the spec. So what does it look like to do WebDriver BiDi? Well, let's take a look at the at what our at some demo code, and this is the repo for where the demonstration code is running from. It is it's WebDriver BiDi.net. It's under my personal GitHub repository, and this is just a. Let me be very clear about what this repository has in it. This repo has in it a client for WebDriver BiDi. It's written in C# or written in .NET, and it is a very low level client. It's not a Selenium client. It's not intended to be used for base level test automation. It's not ready for that. It's not intended to be that. So if you decide to check out the repo just to see what the protocol looks like, or what that would look like, don't expect it to be easy to use or user friendly or anything like that. This library is intended to be, first of all, an implementation, to an independent implementation. I anticipate that the code from this repo will probably make its way into other repositories at some point, either copied and pasted or imported, because it is MIT licensed, so people are free to do with it whatever they want, or as a dependency. It's not published to NuGet yet, but someday it probably will be. So that is the thing. The other thing I want to show is I do have a local site that I'm running just on localhost for the purposes of this of showing this demo. This is the demo site, and as I go through the different scenarios, we'll come back to this page and show what's actually happening here. Let me show the demo harness also really quickly. So I mentioned that you don't need to use Gecko driver or Chrome driver to be able to make this all work with WebDriver BiDi. You can talk directly to the browser. However, those browser drivers do have a mechanism by which you can start a WebDriver Classic session and have it upgraded to a BiDi session. For the purposes of this demo, I have chosen to use the existing browser drivers, mainly because for Firefox, I didn't want to have to figure out how to create anonymous profiles. For Chrome, there's some additional setup work that needs to be done to make it to allow Chrome to talk to across using the BiDi protocol. So I am using Gecko driver and Chrome driver in this demo. Strictly speaking, it's not necessary. This library assumes that you have it assumes that you already have a WebDriver, or sorry, an open socket connection, or something that will talk using the WebDriver protocol on the WebSocket, the WebDriver BiDi protocol on a WebSocket, and that you have that WebSocket URL. So basically what happens is, so for each of these demonstrations, what you'll see is that we'll launch the demo site for the demo, and then we'll start the browser launcher, and we'll launch the browser, and then we'll initialize our driver, connect to the existing the browser that we just launched, and then we'll run our scenario, and then we'll pause 3 seconds to show the results at the end. That's just a standard pause thing so that we can actually see what happens, as opposed to just quitting the browser and everything goes away. So without further ado, let's take a look at our first scenario. So the first thing we're going to do is we're just as a quick demo, we have a form, right? Standard HTTP form, or HTML form, I should say. And we're going to send in some data. We send some data and we send it and we get a response back. We get a response with the what that basically echoes back what we sent over. So that's the first demonstration. And so if I run this project, this demo project, I'm just do it in the console here, just as I could do it from within VS Code, which is the IDE that I'm using. But we'll just, it happened so fast that you didn't even see that we actually typed everything in there and that's using Chrome. And just to prove the point, and the whole point of the exercise is that this works cross-browser. I can change this to use Firefox and run it again. And it's running, and you can see that we're using Firefox to do the same thing. So let's see about what actually happens here. Looking at the code, what we do is first of all, we subscribe to a couple of events, and that's where you're seeing here that the load navigation, the load event has completed. That happens there. That's being printed out by when the onload event of the browser actually happens. I subscribe to an event that does that. I get that notification back from the browser without me having to worry about it. So I have to find out what actual browser window I'm going against, and that's called a browsing context in this case, in WebDriver BiDi. So I get the active browsing context and navigate that browsing context to the appropriate URL. I call a JavaScript function doing query selector to find the input element on that form and evaluate that function, or call that function. From the result of that function, if it's a success, then we take the result of that function, which is going to be the element, the node, and turn it into the appropriate type of thing so that we can send it using the input mechanism for WebDriver BiDi, which is a module. WebDriver, the protocol is listed in modules. Now I have a couple of helper classes in the repo that help me to build these payloads, because for inputs, just like in the WebDriver protocol, the input payload is pretty complex. And so I've added in here, I've got a couple of extra helper classes that help me to do things like build the appropriate input payloads. So I'm clicking on that element, and then I'm sending hello WebDriver BiDi and the enter key, which will submit the form, and then performing the action. And then and that's what the test does. And as you can see, like I said, we pause for 3 seconds then to show that yes, we actually did submit the form, and that was the value that we sent was hello WebDriver BiDi. So that's the first demo of things that we can do with the, it's a standard sort of WebDriver type thing that you can do. And that's that's just one way of, it's a different way of approaching it. But here's some, with WebDriver BiDi, there are some fun things that you can do with that the base WebDriver protocol or the classic WebDriver protocol don't support. So for example, here's a long loading page. I've got a page that what it does is it's got a set timeout in it, right? And so the load event will fire long before the page is actually loaded. And what I really want to do is I don't want to proceed until I've got a custom latch on the page. So until a certain property on the document gets turned to that it's loaded, and it pauses for 3 seconds roughly to do. So what this does is that I've got an event here. What I'm doing is I've got an event that is in the script module, that on a message from the browser, I check and see what the channel ID is. That's part of the payload that comes back across in the message. If it's the right channel ID, then I have an event that I can wait on. This is just a syncing mechanism that's available in C#. That I can wait for this event to be triggered, or my code will wait at that point until it gets triggered, and then I subscribe to that event here in my subscription. Once again, I find the appropriate context. Here's again another feature that's built into the WebDriver protocol, or WebDriver BiDi protocol, is what we call preload scripts. So I have a script here. This is a piece of JavaScript that polls for every second for the custom latch property of the document. Now, obviously, the normal HTML document doesn't have that particular property, but my JavaScript on that page sets it. And so it polls until that happens, and then when it does, it'll send a message back across the protocol through the channel variable that lets me that signals that, okay, that JavaScript has run and has fired. So I can, and this script will get loaded on every page that loads in the browser. So that's the beauty of the preload script. I'm adding it as a preload here, add preload script. So that loads the things in preload. Then I navigate to the delay page. I wait for the navigation to complete. Notice that I'm waiting. That's part of the navigation protocol. And then I wait for up to 10 seconds for my event in my event handler to be triggered. And so so I'm waiting for that to happen. So my method here will pause until it receives that event from the browser, or until it times out. And once I get that response, then I'll call another function that will give me what's the style of the element. And remember, what we're doing here is this is the element that we're looking at. It should have a background color of green or dark green once the timer has expired or has written. So that's what we should see. And if I make sure I save my code so that when I run it from the command line, we're launching the browser, we wait, and now we're pausing for 3 seconds because we want to see the results, and we quit. So you can see here where the navigation has started. This is when I call navigate, I get an event that says navigation started. Here's where the load fires, and this is the navigation was completed here. Here's where I got my event from the preload script. That's in my event handler here. See, I'm just writing it to the console. Receive the event for the preload script. That's the validation that I actually got it. And then here's the result of that script. The element background color is RGB 0100, which is dark green. So we know that it waited until that event was received before continuing on with the rest of the method. And so the important thing to recognize here is that I don't have an explicit polling wait. I'm not repeatedly sending commands across the wire and saying, are you ready? 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 And then only continuing when I get back an affirmative response that yes, the page is in the state that you expect it to be. What I'm actually waiting on is I'm waiting for the page to tell me when it's in the appropriate state, which is something of a game changer in the way that we do, in the way that we're used to automating browsers, in the WebDriver world at least. So, and once again, I'm going to go back to Chrome because this is a cross-browser automation library. Now I'm starting up a new instance of Chrome, and I happen to be starting the and we're paused for 3 seconds now, so you can see that we're in the pause. I put that again. We saw that I put that pause in there so that we, if I were to remove that pause and run it again, this is pretty, just to show that it's quicker than sort of your standard WebDriver kind of thing. And that's and it shuts down. It doesn't wait for that 3-second delay. So that's another kind of fun thing. Now, something that people have often wanted to do in WebDriver Classic scenarios is they want to monitor the traffic that happens between the browser that they're automating and the web server that the page that's being automated. And so WebDriver Classic does support that functionality, but only by using a proxy. So the idea is that you would have the browser use a proxy, and if you use a software programmable proxy, you can it allows you to do whatever you want with it by standing as a man in the middle. Well, the browser, WebDriver BiDi has network traffic monitoring built in. So let me show you what that code looks like. So what I'm doing is I'm setting myself up an event handler for the response completed event. So when an HTTP response comes back from the web server into my browser, then I'm looking at the data coming back across the wire and saying if the URL contains HTML or it ends, the request ends in a slash, it's a directory listing, then I'm going to write out the response code, the HTTP status code for the browser for the HTTP response. If it's between 300 and 400, that's going to be a redirect, and so I'm writing a slightly different message out to the console. But if you want to see what all the stuff is that you can look at for in the response, I've got URL, the status. I've got all kinds of I can look at the body size, the bytes received, the content of it. I can look at the request that was sent, and so on and so on. There's all kinds. I can get the timings, the navigation timings of the request. So when timings start and end. So this is all built directly into the WebDriver BiDi protocol. You don't have to drop out and write your own or roll your own instance for that. Let's see. So I have to tell the driver to send me that event. So I've subscribed to it. Once again, I have to get the context or the browsing window that I'm automating. And what this test is going to do is I've got 3 URLs that I'm going to navigate to one after the other. One is going to be just the base slash URL, which there's a redirect in this code. So for example, when I navigate to localhost / it redirects to index.html. And then I'm also going to navigate to this simple content page, which just has some simple content on it. That's our new kitten. He's so cute. And then I'm gonna navigate also to a page that doesn't exist. So to show that I'm getting, so that I can get the right status code, 404 in this case is what I should get back in this case. So let me go ahead and run that test from the command line here so we can watch it run. And this will go pretty quick. You notice it just scanned through those three very quickly, and we still did the 3-second pause. So you see that there. And that's but as you can see here in the demo, as we launching the browser, we've got our connection, we've got our context. In the first case, the blank URL, it redirected from localhost to localhost index with response code 301, which is just a moved code. The response code for the simple content page was 200. It was a successful. And for the missing page or the non-existent page, it was a 404. That's exactly what I expect. And then these log messages, these things preceded by log message, they are part of the part of the library itself. This demo library has some interesting, has some features in it. You can get more detail of what's happening if you really want to see stuff. You can see there's a lot more information that comes back when you go debug. This actually, using debug for the logging actually shows everything actually being sent across the wire in the protocol. Here's what was sent by the local for navigate. Here is where we received the network, or the response completed event is here. Here's where we received it. That's the payload. You can see all of the data that it sends back across the wire. And then here's the result of the command where we told it to navigate. So you can, with the library, this demo library, you can inspect what's actually happening with the protocol, and it supports several different levels of logging. I'm just going to keep it at info for this demonstration. The last demo I want to show you, and again, this is stuff that either is challenging to do today or can't be done using the WebDriver protocol proper, or the classic WebDriver protocol. One of the things that people often want to do is they want to see when the browser, when any JavaScript on the site that they're automating wants to or writes to the browser console. So you do console.log. You want to see when that happens. So there is a log module in the specification, which defines an entry added event. And so so what I'm going to do here is I'm going to subscribe to that event, and when that event happens, I'm going to write to the console that's going to tell me when it was written, at the timestamp that it was written, and in UTC time, and what the text was that was written to the log. And just to show you what that does, I'm going to go and show that. And if I open up the browser console, you'll see it says here, you probably can't really read it very well here, but it says hello from the browser console. What this page writes to the browser console, to the JavaScript console. So if I go to run this code, and make sure I've saved everything. So this is going to basically just navigate to that page, because it does the writing to the browser console on the onload property. So and basically all this does is it just writes out to my my test console what was written to the browser console. Every time something gets written there, so we pause for 3 seconds. And so at November 21st, 2023, at 15:40:22 and 215 milliseconds UTC, it wrote hello from the browser console was written to the browser console. And so that's another scenario that's, again, challenging to do often with today's WebDriver Classic protocol, or tools based on the WebDriver Classic protocol, but it's built into the WebDriver BiDi protocol. And once again, you'll notice that I'm not polling for anything here. The browser is just sending me that event. So anytime it happens, I get notified. Now, of course, what happens within this event handler method is entirely up to me. In this case, I'm just writing it out to standard out, but you could collect everything that you could consider maybe in a test. You collect everything that was written to the browser console, and then assert things on it, or assert that nothing was written to the browser console if you don't anticipate if your app shouldn't be using console.log in production, or whatever you want to do, or you want to wait for a certain thing to be written to the browser console. You could have your event handler have a synchronization object in it, and wait for that synchronization object to be signaled. So that's the the event-based protocol, or having events available to you, really opens up a lot of additional scenarios that today's testing tools, or at least today's WebDriver-based testing tools, have some challenges in doing. So that kind of gives you, in a nutshell, some of the things that the protocol itself is capable of. Once again, I want to mention this is a draft protocol, or it's still being developed. There's still a lot of things that are still to come. If you look in the repository, there's a roadmap that says that gives us the scenarios that we are trying that we want to make sure that we cover. Cookies there's an open PR about cookies right now for setting and getting cookies in through the protocol. It is an express design goal of the WebDriver protocol, a WebDriver BiDi working group, and that you should be able to do everything from WebDriver Classic using WebDriver BiDi. That is an explicit design goal of the WebDriver BiDi working group for this specification. So eventually, the goal is that anybody who is currently using WebDriver Classic to drive a browser, any project that is using WebDriver Classic to drive a browser, will eventually be able to move their code to use WebDriver BiDi and be functionally equivalent. That, of course, depends on two things. That depends on the specification supporting it, and browser vendors then implementing that part of the specification, which is, like I said, that effort is ongoing. We welcome contributions. If you have suggestions for features, look through the issues list and see if that feature's already been requested, or see if there's an open pull request that maybe already has a start on implementing it. So that's the demo. That's a little bit about WebDriver BiDi. I'm going to stop sharing my screen right now, and there we go. So I hope that was useful. I hope that showed some of the things that WebDriver BiDi is capable of, and how it works, and what sort of things it enables, as opposed to sort of the WebDriver Classic. So looking forward to answering questions if people people have questions that they want to answer, that they want to ask about WebDriver BiDi. Feel free.
Thanks, Jim. Yeah, there are quite a few questions. Before I jump on, I wanted to ask a few questions related to the WebDriver BiDi that I've been getting in from the community, not specifically from this session, but elsewhere in different Slack channels, as well as a few unanswered questions from my talk that I gave a couple of months back. So it's all from a user perspective, Jim. So that back in time when we transitioned from Selenium 2 to Selenium 3, right? So we're from an RC protocol to WebDriver protocol. So now we are looking at the futuristic transition from the WebDriver protocol to WebDriver BiDi. So from a user perspective, what are some of the changes that they can expect?
Well, so currently a lot of the features that people want to do bidirectional communication for are there's already an API for a lot of them in the Selenium project, for example, like network interception, for example. Those APIs already exist, and they are already implemented using the Chrome DevTools protocol for browsers that support the DevTools protocol. The problem with using the DevTools protocol for browser automation, especially in a cross-browser way, and that's the important key thing, is that's the whole thing, is that it's cross-browser. You can take the same code and run it against Chrome, Firefox, Safari, and so on. The 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 protocol, the idea is that the Selenium project, for example, to take one example, will keep the same API, but instead of using CDP for doing those bidirectional types of communications, like network monitoring or monitoring the browser console, those APIs already exist, but instead of using CDP, we'll switch out the implementation underneath that API to use the WebDriver BiDi protocol, which gets us a lot more flexibility and that cross-browser implementation that perhaps we hadn't had, because, like, for example, Firefox does not implement all of the network domains, CDP domains, that are required to do full network sort of monitoring in Firefox. So currently, the network monitoring APIs in the Selenium project and all the language bindings will only work for Chromium-based browsers. They won't work for Firefox, because Firefox doesn't support that version of CDP, or doesn't implement those all the modules or all the domains that are required. In WebDriver BiDi, it's built in. So once we swap the implementation out to use WebDriver BiDi, you pick up Firefox implementation or Firefox working for free. So
Thanks, Jim. Yeah, that sort of answered the next question I was going into, because in the documentation, we have to have the CDP implementation. And then we say this is the interim and you should be looking forward to use BiDi.
Yes.
So there's a bit of a confusion, and quite a few people get lost, and we do get sort of questions in the Slack channel. So thank you very much for answering that. So
by the way, everything I was showing today was stable channel. So I'm not using like Nightly or Canary for Chrome. I'm using the stable channel. Everything I demoed today is in the browsers themselves right now. So those implementations already exist.
Thank you. Thanks for writing that. Jim, the next question that I have is around, in one of the slides you mentioned, the spec has been authored by the major tool vendors, the browser vendors like the Microsoft, yes, Apple, Mozilla, and all of them. So if you could just give a quick snapshot, because apart from the spec team, it'll be good to hear from a user perspective what exactly happens in those discussions.
So we have a monthly meeting, where we discuss, open issues in the spec, review pull requests, all those things, and the discussions are around finding consensus around what feature, how a feature should be specified to operate. That's what those discussions are like. A lot of the discussion happens in PR comments. I wrote a feature for locating a node using methods other than JavaScript. And you can see that if you look at the history of when that PR landed, you can see all the different iterations that it went through before and how it changed from the initial proposal to the final proposal. That command, the locate nodes command on the browser context module, is in the spec. That spec change landed. So, but the conversations are all around how do we support these things across in a browser independent way is the biggest way to do it. Yeah, so that's the biggest thing to do.
Cool, perfect. Thank you. I'll try to be as dumb as possible. It's nothing like someone asked me, it's going to be a one-to-one mapping of WebDriver spec and then see how to port into WebDriver spec, the BiDi spec. So that's why I wanted to ask from a user perspective questions to make it very clear, because what we saw today was more of a developer perspective on how things happen in the spec and how you could look forward to implement. And I hope I think your answer was pretty sweet and short in answering that. Thank you.
Yeah, for Selenium, you should probably not expect a whole lot in the way of API changes. The idea is simply that all of this stuff that I was showing today and all that complicated code gets hidden away from the user as part of the implementation for the specific language implementation or a wrapper library around the protocol. I'll point out that Puppeteer, the Puppeteer project from Google, that automation project is committed to. It currently uses the Chrome DevTools protocol to automate browsers, and they are committed to migrating their code base to using WebDriver BiDi as well. So they will automatically become fully cross-browser compliant once that migration happens.
Yeah, so sort of speculate actually enable those tools to become cross-browser.
Okay.
Cool. I'm going to pick one question from the Q&A.
Okay.
It's from Nicole.
Okay.
Like all the examples with WebDriver BiDi use a local browser. I think the question is around how do we expect, when do we expect Selenium Grid implementation, to support the WebDriver BiDi?
Well, so it's just a WebSocket, right? So what all you would need is there would need to be some sort of middleware component like Selenium Grid that understands how to use a WebSocket and can multiplex a WebSocket connection across to or redirect a WebSocket message both to and from the local machine. It would take in the WebSocket request and proxy it over to another machine, which would then then it receives that proxy works both directions. And the Selenium Grid, I believe, already has support for proxying WebSocket connections. So I believe that already works. All we would need to do then is have the middleware piece to be able to understand the protocol itself, which that implementation, of course, hasn't happened yet. But once it does, then that should be pretty straightforward and again, that depends on what the middleware piece looks like, right? So a cloud provider will need to update whatever they're using on their end to do that sort of proxying of calls to understand WebSocket messages and to understand how to proxy those the WebDriver the WebSocket messages.
Thanks, Jim. Simon, +1's your statement, and he mentioned Grid can proxy WebSocket connections. That's taken me to an interesting question. Is that how Playwright supports running it on Selenium Grid, Jim?
So right now, currently, all Playwright support's doing is launching the browser remotely through. That's all it does through the Selenium Grid. At least the last time I looked, that was all it was doing. And then it did a direct connection from Selenium from the local end to the remote end. That's my understanding. Last time I looked at it, maybe they've changed that, but the last time I looked, all that Playwright did for their remote, when using Selenium Grid remotely, all they used it for was to launch the browser. And once the browser was launched, then they used a direct connection. That could have changed. I don't know. I don't know the internal workings of Playwright that well. I know a little bit about it. Yeah.
Let's talk about it, Jim. Given, as we say, this is the future of the browser automation, and given, as you mentioned, this will enable tools like Puppeteer to truly become a cross-browser from being just a browser-dependent automation framework. Well, how does it hold when we compare it to other frameworks that we have in the market right now, like the tools like the Cypress, Playwright, and Puppeteer, for example? How do they collaborate with us? Let's talk about from the technical point of view as well as from a collaboration point of view.
Sure. So the project and the spec working group is very open to collaboration, and we want input from other projects and other potential client users. We want that participation from people. The Puppeteer team at Google has been incredibly responsive, and in fact, some of the people who work on Puppeteer are actually working as members of the working group that they actually participate in the spec process. So that's how I know that Puppeteer is committed to using WebDriver BiDi or migrating to WebDriver BiDi. To date, we have not had any participation. While Microsoft as a company participates and has people participating in the working group, as I'm sure you know, or you may not know, the Playwright team works under the Developer Tools division, and the browser team, the one that produces Edge and Edge Driver and all of that, is part of the web platform team at Microsoft, and they don't really report to the same reporting structure, and it's a little bit left hand, right hand in terms of how that works. I would imagine that it would make more sense for the Playwright project in particular to move to WebDriver BiDi at some point. But there may be scenarios that because I know that they use the Chrome DevTools protocol for some things right now. But it makes sense that they would want to move to WebDriver BiDi, but I can't speak for that team. We would welcome their input, but up to this point, they haven't had any that particular team has not had any participation with our project, despite we have reached out several times. I know I've reached out personally to that team, and we have not gotten any responses for collaboration in that sense so far. As far as like Cypress, Cypress being Cypress, I have no idea what they're thinking in terms of, you know, they're a privately funded company with you know, that I do not have any sense for whether or when they would be changing their technology to use WebDriver BiDi instead of CDP, or if they ever plan to. I know they looked at using the WebDriver protocol and rejected using the WebDriver protocol for reasons that I didn't agree with at the time. And again, we would welcome input. We would welcome the folks at Cypress coming by and talking about what their needs are and how we could help WebDriver BiDi meet their needs as a project. But that sort of participation hasn't happened yet. I haven't heard anything from them as far as that goes.
Thank you. Thank you. I remember seeing a tweet as a response to David Burns that they would like to collaborate. Hopefully they come at some point.
I hope so.
And make the browser ecosystem more collaborative. Thanks, Jim. Slightly moving on to there's a question around how does BiDi help in weight strategy? I think it's something related to the one that you showed about. In Classic, you would be polling to know about a page load, but in BiDi, it doesn't do that. So if you could enhance a bit more around how does the API change?
Yeah, so that really is a client side. That really is sort of a client side coding question more than a protocol level question. But because we have the ability to receive events from the browser when a certain things happen, that means that you don't have to continue to poll for a condition and send a command and get the response back and check the response to see if your page is in the condition you want. You could, for example, let's take for instance, you could set up a mutation observer in a preload script so that every time the page loads, it gets a mutation observer, and you could wait for if you know a specific element is going to have a certain state, you could in your code have an event handler for the JavaScript channel event from the preload, like I showed in the second demo example I gave, and it would just wait until it received that event from the browser rather than continuing to poll for it. And that's using a programming language level construct, not a protocol level construct. In this case, I was using a C# a C# construct, which is it enters a wait state until the event object is signaled, and that's how that works for for C#. There would be similar types of wait mechanisms in Python or Java or whatever. So that would be a programming level construct, and it would be easier for, you wouldn't, again, it would reduce the traffic across the wire because you're not continually polling every half second or however long it, whatever your interval is, sending a command and getting a response back. You simply wait for the event to happen, and you just get the notification coming into as an incoming message and process it there.
Got it. I know we are actually past the actual time, but when we were actually about to start the session, Jim was kind enough to support and extend more time, because we know we would be more questions, and as we expected, there are a few questions, so we're gonna extend and spend a few more minutes. And Jim is okay with that, and
That's
if
fine.
you do have a time, please stick around, and look forward to Jim answering all the interesting questions about BiDi. With that, the next question is around how does the WebDriver BiDi support is with the mobile browser automation with Appium? Or rather, I would extend, Jim, it's not only with Appium, right? So any automation framework that are based on WebDriver right now, what they should be looking forward to BiDi when it, right from Appium to the other tools?
Yeah, again, so it's a matter of the project would then need to implement the a WebSocket aware piece of software to handle WebDriver BiDi messages. And in the case of like mobile automation, for example, Appium, the Appium server would need to understand WebSocket messages and would need to understand the WebDriver BiDi protocol. And rather than, it's just a matter of, instead of talking HTTP, you would talk across the WebSocket, and they would translate the commands that they get from the WebSocket across the wire to whatever the native automation pieces are. I will mention that I've not talked with the Appium team about extending this to mobile automation. And it's worth noting that the specification and the working group in the specification is currently focused on the web case, because it is a web spec. I'm hopeful that projects like Appium and so on will be able to adapt to use it, much in the way that they were able to adapt to the WebDriver Classic protocol. But that really is something that would be better answered by the maintainers of the additional, the mobile or desktop automation libraries.
I see there's a potential for a lot of cross-project collaboration, isn't it, Jim? Because the Appium is just one case, and I think there's also other related questions around from Nikolay, where he says Safari is a bit slow in terms of the working state when we compare to other browsers. So what are your thoughts on that?
Well, so when it comes to Apple, we love our friends in Cupertino. They're good people. But they, as a corporation, tend to play their cards very, very close to the vest. They do not announce things. They don't announce, they tend not to announce upcoming work, or they don't want to promise features or have a statement of availability that could be construed as a promised feature and then it not ship at the appropriate time. I do know that we do have participation of people from Apple in the working group on the specification. So I do know that they're aware of the spec and they are contributing actively to the discussions of the spec. I have no idea. I have no insight whatsoever into the timeline for when their WebDriver BiDi would be integrated into Safari or Safari Driver or any other. I don't have any insight into what Apple's idea. But that's when it comes to Apple. For other automation projects or automation tools. Again, we really welcome that collaboration in the in the working group. We'd love to hear what their needs are. We'd love to talk about it. Obviously it's a discussion. The answer may end up being no, I don't think that's the way we're going to go in this particular specification, but we're always open to having that discussion, and would definitely like to have that participation from other ecosystem or test automation ecosystem projects.
Good, thank you. I'm afraid to ask this question, but you mentioned about not knowing the internals of Apple, which is fair enough. Now, this question was around what's the timeline for the spec itself? I know it's Christmas time. I know Simon is here. He mentioned about it once that it'll be in Christmas, and it took a couple of Christmases to pass by. But yeah, the spec, talk about it.
I'm sorry, I missed a bit of that question. We had a little bit of a freeze, glitch there. Can you give me can you repeat that for me?
Sure. Yeah, I made a friendly disclaimer saying I'm afraid to ask this question because it's Christmas time. There's a question around when the spec will be ready. What's the timeline? So
got it. Okay, so what is the timeline for the spec? Well, the timeline for the spec is when it gets done. It's a matter of like I say, there are two pieces to the implementation. I mean, there's multiple moving parts, but there's the actual spec language that needs to be written. And writing spec language is a bit of an art. The prose has to have a specific style in order to be implementable by a reader of the specification. And so that's the first part, is that we need to have the commands and events and modules fully specced out or fully specified. And that's dependent on who and how quickly the PRs get written and the spec prose gets written. The second piece is that the browser vendor or the remote end vendor has to do an implementation of the project of that specification. And in order for a W3C spec to go to recommendation, part of the process is that you have to have two independent implementations of that specification. So the prerequisite for having the spec become a recommendation, which is the final stage of a W3C specification, is that multiple vendors would have to have an implementation available for that spec. So we do try to encourage things like having implementation tests in the WPT test suite, so that a potential implementer could easily check that their implementation does what it's supposed to do. And like I said, I showed the tests that are already implemented there. And again, that's all a GitHub repo. Tests are added via pull request, just like anything else. So that's where we're at. That's how that happens. So as to when, that's up to, that just depends on how quickly people get specs done and PRs reviewed and merged into the main branch of the specification. There's not a specific timeline associated with that. And when is the spec complete? Well, it's done when the working group says it's done. We have a roadmap. Once we get all of the scenarios available in the roadmap, that are all the scenarios that are implementable in the roadmap, then I think that's what we're currently targeting as being sort of a definition of done. So if there are scenarios in that roadmap that you think are missing, and by you I mean anyone who's listening, feel free to bring those up.
Thank you. Thanks, Shem. We're already 10 minutes past. We didn't really look at the time, but I think that sort of creates a good segue for ending our webinar today, talking about what's the timeline for WebDriver BiDi and really setting expectations on what to look forward. So thank you everyone so much for joining us today to hear about WebDriver BiDi. That was an interesting demo, and we will share all the GitHub links and in fact the whole deck. The session is recorded for those of you who joined late, and it will be posted in the playlist that we have in the YouTube. And yeah, look forward to having you all in the next edition. And thank you so much, Jim. I hope you do really enjoy the questions as well.
Absolutely. Anytime,
Thank you.
Manoj. It's always a great to talk to you.
Thanks, Jim, and happy Thanksgiving to you, to your family, and for all of you who's listening to the talk, and Merry Christmas too, if you didn't get a chance to talk to you before that.
All right. Well, same to you, and have a wonderful holiday season.
Thank you. Thanks, Jim. Thanks everyone again for joining, and I look forward to seeing you in the next episode of Voice of Community to December. For those of you who are following this series, they would know usually the December is actually a panel discussion where we would look forward to having experts in the panel talking about how the year went by and what to look forward in 2024. So the planning for such webinar is actually underway, and you will see such announcements shortly. So I look forward to seeing you in next month edition. Until then, happy holidays and happy New Year if we don't meet then. Thank you, everyone. See you. Thanks, Jim.
Thank you.